Hello everyone. In this video we are going to look at something called as the machine cycle and CPU timing cycle in 8051. So what is a machine cycle? A machine cycle basically consists of the steps that are performed by the computer processor for each machine language instruction that it receives. So basically it is a 4-process cycle, and that includes reading, interpreting, executing and then storing that code. So let's talk about the 4 steps that I mentioned. The first step is fetch. So what happens in fetch is that the control unit, it requests some instructions from the main memory, okay, which has been previously stored in the main memory by a previous program that we have written. Then after it gets fetched, it goes to decode. So what happens in decode is that the received instruction is decoded, or you can say it's broken down into the various computer commands. The next step is the execution. So in execution, what happens is basically the CPU operation, the processor CPU operation, it executes whatever command it has been given. Example, if it has been given add command, so it will add. If it has been given multiply, then it will multiply and such. Now finally we have the store, and in this what happens is whatever the results that are coming from the execution of the program, it is sent and written back into the memory. So I've drawn a simple diagram to show that flow. So the first step is to fetch the instruction from the main memory, and this fetching is done by the control unit. It asks for the instruction, the control unit then decodes those instructions, then finally it is given to actually ALU, which executes whatever instruction it has been given, and finally it goes back, or the result is stored back into the main memory. Now the length of machine cycle, okay, depends on the frequency of crystal oscillator. So how much time it will take depends on the frequency of what oscillator is being used. So in 8051, generally, to make it compatible with the serial port of my desktop, laptop or PC, a 11.0592 MHz crystal is used. But you can use anything between 4 and 40 MHz. Okay. Next, now in 8051, one machine cycle lasts 12 oscillator periods. And to calculate the machine cycle, we first take 1/12. Why? Because it has 12 oscillator periods of the crystal frequency, that is 11.0592 or anything, and then take the inverse of its results for time period, because frequency is equal to 1 upon time period. Now let's solve some examples to get a better understanding of this. So suppose you have a 11.0592 MHz crystal. Calculate the time period. So I have this crystal, I first multiplied by 1/12. Why? Because in 8051, one machine cycle is 12 oscillator periods. I get 921.6 kilohertz. And now the machine cycle time period will be equal to 1 upon this, which is equal to 1.085 microseconds. Similarly, if suppose you have a 16 megahertz crystal, then in that case, first we multiplied by 1/12. It gives me 1.333 megahertz. And then machine cycle can be calculated as 1 upon this equal to 0.75 microseconds time period for one instruction to get executed. Okay, or I can say for one machine cycle. Now for each instruction in 8051, it has a fixed machine cycle for execution. So I have given a list of instructions, or the opcode I can say. And this is not an exhaustive list. You have many more. I'll try to provide some link in the description. Please do check the description. So example, what we have here is, let's say, a add instruction. Now in this add instruction, if I, let's say, add a register, Rn is a register, to an accumulator, it is equal to 1 machine cycle. Then we have ADDC, that is add register to accumulator with a carry. Again, this is a 1 machine cycle instruction execution. SUBB, that is subtract register from accumulator with a borrow, and that is again equal to 1 machine cycle. Next is mul, that is multiply. Here we have multiply A with B. Okay, or we can say multiply A and B and it is equal to 4 machine cycles. Okay, 4 machine cycles, and that is basically 12 into 4, that is 48 oscillator periods. Next we have div, that is nothing but divide A by B, divide A by B, and that is again equal to 4 machine cycles. Then we have MOV, that is nothing but move. So what we are moving here is we move the register to accumulator, and that is 1 machine cycle. We have move A comma hash data, that means we are moving the immediate data to accumulator, again that is 1 machine cycle. And this is LJMP, that is long jump. It has, let's say we have a 16-bit address, and that is equal to 12 machine cycles. Okay, and this 16-bit address is basically the 16-bit destination address where we have to put something. Let's solve some examples. So we are given a 8051 system with 11.059 megahertz crystal, and we have to find the time to execute the following instructions. So MOV R3 comma hash 55, that is nothing but this type of equation where R3 is basically the register, and you know for MOV it's 1 machine cycle, so time to execute will be 1 into 1.085 microseconds. 1.085 microseconds came from here, so that is again 1.085 microseconds. Mul is multiply, it has multiply has 4 machine cycles. Okay, so here it will be 4 into 1.085. Ljump has 2 machine cycles, so 2 into 1.085. And dec, that is nothing but decrement, so we are decrementing here the R3, that is register. So that is, again I haven't written it here, but decrement takes 1 machine cycle, so time to execute will be 1 into 1.085, that is 1.085 microseconds. So that was all about machine cycle and timing of microcontroller 8051. Thank you, see you in the next video.